Dear students, in this tutorial we shall see few important examples of NCERT. First question is, find the angle between the vectors A and B. The vector A is given and vector B is also given, B vector is also given. So you have to find out the angle between them. So first of all, what to do? You have to find out A dot B vector, A dot B vector, that is equal to I plus 2j cap plus 3k cap dot B vector. B vector is equal to minus 2j cap plus 4k cap. Okay, this is equal to 1 into 0 plus 2 into minus 2 plus 3 into 4. So ultimately you are getting here 0 minus 4 plus 12 is equal to 8. Okay, A dot B is equal to 8. Next you have to find out modulus of A vector. Modulus of A vector is equal to root over of here the coefficient of I is 1, so 1 square, then plus 2 square, then 3 square. So you are getting 1, 4 plus 9. So this is equal to root over of 14. Next you have to find out modulus of B vector. What is B vector? B vector is given this one. So 0, because the coefficient of I is 0. So 0 plus minus 2 whole square, that is 4, plus 4 square, that is equal to 16. So root over of 20. Let the angle between these two vectors, write it here, let the angles between the two vectors be theta. So we can write cos theta is equal to A vector dot B vector divided by modulus of A vector into modulus of B vector. Okay, so A dot B vector is found. This is 8 divided by modulus A. What is modulus A? Root over of 14 into root over of 20, because mod B is given, found root over 20. So this is equal to 8 upon root over of 14 into 20. So this is 280 is equal to 8 upon 2 root over of 70. So 2 is cancelled, 4 divided by root over of 70. So what is theta? So ultimately this is cos theta, actually this is cos theta. So theta is equal to cos inverse of 4 upon root over of 70. This is the angle between the two given vectors A and B. Two vectors were given. One vector is A, this is A vector, another vector is B vector, and the angle between them, we consider the angle between them as theta. So the theta is found. Theta is equal to cos inverse of 4 divided by root over of 70. In the next question, so we take the next question. Okay, this is the next question. Find the real value of lambda so that the following vectors are perpendicular. Two vectors are given. First vector is A vector, second vector is B vector, and they are perpendicular to each other. Suppose this is B vector and this one is A vector, and they are perpendicular to each other. This is given. So using the condition of perpendicularity, you have to find out the value of lambda. Okay, so since you write it here, since A vector and B vector are perpendicular to each other, so A vector dot B vector is equal to 0. You know this one, we discussed this property. A vector is equal to I cap plus j cap plus lambda k cap. Okay, dot B vector. What is B vector? B vector is equal to, this is given also, 2I cap plus lambda k cap is equal to 0, or I into 2i, that is equal to 2, plus j into, there is no j, so 0, plus lambda k into lambda k, that is lambda square into 1, that is equal to 0, or lambda square is equal to minus 2, therefore lambda is equal to plus minus root over of minus 2. Now see that root over of minus 2, this value is not a, sorry, this is not written actually, this value root over of minus 2, okay, root over of minus 2 is not a real number, this belongs to the set of complex number, this is an imaginary number, you found it in complex number, the value of root over minus 2 is equal to I root over of 2, this is 0 plus I into root over 2, this is a complex number, so this there is no real value of lambda, so you can conclude here there exists no real value of lambda, okay, there is no real value of lambda. So this question is very important, it comes actually in CBSE exam. So again I discussed, it may again be set in your next exam also. The vectors A and B are perpendicular to each other, they are orthogonal to each other, this is another term, orthogonal, okay, orthogonal vectors. So since they are perpendicular to each other, so A vector dot B vector is equal to 0, and put the vector position vectors of the given vectors. So the dot product is taken, so 2 plus 0 plus lambda square is equal to 0. From this you are getting lambda is equal to plus minus root over minus 2. Root over minus 2 is a complex number, just we discussed it here. I root 2, that is 0 plus I root 2, so belongs to the set of complex numbers. So we do not find any real value of lambda for which A and B could be perpendicular or could be orthogonal to each other, okay. So in the next example, it's a CBSE question. If A vector, B vector, C vector, B three vectors such that the sum of the vectors is equal to 0 vector and the modulus of A is equal to 3, modulus of B vector is equal to 5, modulus C vector is equal to 7, find the angle between the A vector and B vector, okay. So let us consider that theta be the angle between these two vectors A and B, okay. There is a problem in my cursor, so please. This is A vector, say, and this one is B vector. Let us consider that the angle between them be theta. So what is given? Given that A vector plus B vector plus C vector is equal to 0 vector, okay. So from this you can write A vector plus B vector is equal to minus C vector, or you can write this one, A vector plus B vector dot A vector plus B vector is equal to minus C vector into minus C vector, or A vector dot A vector is equal to modulus of A vector, or you may write it again, A vector dot A vector plus B vector dot B vector plus A vector dot B vector plus B vector dot A vector, and this is C vector dot C vector, or you can write modulus of A vector square, modulus of B vector square, and A dot B is equal to B dot A vector, so you can write twice of A vector dot B vector, and this is C vector modulus C vector square. Now again you have to write this one, A vector square plus b vector square plus 2 a dot b vector is equal to, use the scalar product rule, modulus of a vector modulus of b vector into cos theta, that is equal to modulus of c vector square. Okay, or modulus of a vector, this is given 3 square, that is 9, plus modulus b is equal to 5 and square 25, plus 2 into modulus a is equal to 3 into mod b is equal to 5, cos theta unknown is equal to mod c is equal to 7, 49, 7 square is equal to 49. So 2 into 3 into 5, that is equal to 30. 30 cos theta is equal to 49 minus 34, and it is equal, okay, write it here, 49 minus 34, or 30 cos theta is equal to 49 minus 34 is equal to 15, and from here you get cos theta is equal to 15 by 30, that is equal to half. So you are getting theta is equal to cos inverse of half, and this is 60 degree, or you may write pi upon 3 radian. So the angle between the vectors a and b is pi upon 3 radians. Okay, now the next problem, this is also another important problem, and I have collected this one. So we discussed this one. The question is also taken from NCERT. If a vector is equal to this, b vector is given, c vector also given, are such that a plus lambda b vector is perpendicular to c vector. Okay, the a plus lambda b vector is perpendicular to c vector. I change the ink color. Okay, a vector plus lambda b vector is perpendicular to c vector, and next you have to find out lambda. Okay, so a plus lambda b vector, you find this one is very important. A plus lambda b vector should be found, and put the value of a vector and b vector, and make it in the form of ai plus, the shape is ai plus bj plus ck cap, like this format, and this vector is perpendicular to another vector c. So for this, the dot product between them is equal to 0, isn't it? So this vector is found and put it here, and dot c is 3i plus j. So using the scalar product, you are getting 2 minus lambda into 3, 2 plus 2 lambda, here j, the coefficient of j is 1, into 1, and there is no k, for this the part is 0. So 6 minus 3 lambda plus 2 lambda is equal to 0, so lambda is equal to 8. So this is one of the most important question of NCERT book. So you please go through these examples, and I discuss the important examples, and you have to do all the problems in your NCERT book. So in next session we shall discuss on vector product and many more. Till then, bye bye, take care of you.